Hello everybody, glad to see you. Today we need to keep talking about total run out. In this slide I would like to highlight how we are going to set the fixture to measure total run out. As we can see at top, we are going to have this total run out symbol. TZ is 0.009 back to AB. A is axis of this cylinder, B is this plane. It means you are going to have this fixture here. The component can be rotated around axis A and can be set on plane B. During that rotation, the dial gauge moves up and down to measure total run out. In this manner, somehow we are going to control the perpendicularity. Just the way of measuring is going to be different. At bottom, we are going to have another example. Total run out is here. We are going to have TZ 0.005 back to axis AB. It means we are going to have these two fixtures here, and the component is going to rotate around axis AB, and dial gauge is going to move left and right to measure total run out for this surface. In this slide, I would like to talk about the TZ for total run out. I would like to compare the TZ for total run out with the TZ for the size. As we can see here on left hand side, the TZ for the total run out is greater than the TZ for the size. It is highlighted in yellow color, as we can see here. It means somehow we are going to control the off center of this cylinder respect to that axis. On right hand side, we can see the TZ for total run out has a smaller value than the TZ for the size. It means somehow we are going to control the form of that surface. If I'm going to compare the TZ for the total run out in comparison with the TZ of the size and flatness. As we can see at bottom, the TZ for flatness is smaller than the TZ for the size. The TZ for flatness is 0.05 and the TZ for the size is plus minus 0.1. But for total run out, we are not going to have this limitation because we are going to talk about, let's say, off center and form. In this last slide, I would like to do comparison between total run out profile and positioning. As you can see here, for this figure, we are going to have this total run out TZ 0.4 back to AB, and for this cylinder, we are going to have the same value of the TZ back to AB. If we are going to use profile here, what is the difference between using the profile symbol and total run out symbol? As we can see here, we are going to use basic dimension. It means by having this profile, we are going to control the size as well. While whenever we are going to implement total run out, we are going to control location, orientation, and form, not size. But whenever we are going to use profile symbol with basic dimension, we are going to control the size as well. As we can see here, the TZ for profile is 0.4. It means the form is going to change in that interval. It is a little bit wide interval. In order to have, let's say, a small interval, what we should do, as we can see here, on right hand side at top, we can see the size here can be changed in the interval of, let's say, the TZ is 0.3. It can be big or small in that interval. But if we would like to have more constraint for the form, we can use this triangle and use this dynamic profile. It means the form should be in that interval 0.1, but it can be big or small in this TZ 0.3. Now let's compare total run out and positioning. As it was mentioned, total run out is going to control location, orientation, and form, but positioning is going to control location and orientation. If the form of this cylinder, as we can see, if we don't have any error for the form, it means the positioning and total run out is going to be the same. But total run out is going to cover positioning and form as well, positioning and cylindricity. For now, I would like to close this session. In coming session, again, I'm going to talk about total run out. Thank you for today. I hope you enjoyed. See you next time.